So looking at joints in general, a joint is really just where two or more bones come into contact or articulate with each other at a certain point. There are three main types of joints that we see, and these are the cartilaginous joints, fibrous joints, and synovial joints. And really, usually, the first impression that we have of a joint is usually the synovial joint, because those are most commonly found in the body, and they allow for the most amount of mobility and movement. But to start off with, the cartilaginous joint is usually found in your vertebral column because your vertebrae is composed of many little bones that line up to form the column, and in between every one of these little bones, there's a joint that is separated by a fibrocartilage disc or a hyaline disc. And they allow for limited movement, so this allows for your vertebrae column to still support your body upright, but not so much that your body just collapses. And the second type of joint is the fibrous joint. And the fibrous joint allows for no movement at all, and it's quite thin and it lines up the adjacent ends of two bones. And the fibrous joint is really only found in your skull, where like the edge of your skull fuses and is connected then by a fibrous joint. No movement is allowed because we don't want our skull to be moving around. And our third type of joint, and the most common type, is the synovial joint. And it's classified on shape and also the amount of mobility it allows. So because these joints all have different amounts of movement that they allow, one thing we need to remember is that the more movement that is allowed at a joint, the less stable it is, and therefore the more prone to injury it is. And so these factors are really the things that can determine how much movement a joint has. So for example, the first one is the shape of the bone and whether it has any interlocking points. So take the fibrous joint, for example, that's the one in your skull. They're interlocked like this because say this is one edge of your skull and this is the other, and they're all thin, right? Because the skull is a flat bone. So we want these to be locked like this with the fibrous joint in between. And therefore, because it's interlocked, it's more stable and doesn't allow for movement. The second one is the area of contact. So it's just really how big the surface of the two articulating bones are. And then the third one is the flexibility of ligaments, which is the connective tissue surrounding it. And the fourth one is the influence of other soft tissue structures, such as like the muscles or other connective tissue surrounding the joint itself. Okay. But for now, we're going to focus on just the structure of the synovial joint. So this is like a typical structure of a synovial joint, but for this specifically, we'll take it as the kneecap because it's the most obvious to kind of visualize. So if we take this as like your calf and this as your quadricep hamstring group, this is going to be your patella, so your kneecap. And one thing we want to focus on really is the structures that lie between it. So we see that the joint is the part where the two bones meet, so the articulation point. In between it, we need to have the articular cartilage, which is this thin layer of cartilage that really reduces the friction and absorbs shock when these two bones come into contact. Then we have the joint cavity containing synovial fluid, and this is also why sometimes your joints crack when you move them. It's because there are air bubbles being released in the synovial fluid. And then the articular capsule is the one that it's flexible and it allows for the movement of your joints, and it also can be arranged in these parallel bundles to form ligaments, which we'll talk about in another video. The synovial membrane over here is what secretes the synovial fluid inside the joint cavity, and then the articular cartilage, that one we talked about, and the menisci is specifically one that occurs in the knee, and it's just another added layer of protection. So sometimes like when people say that they tore their meniscus, it produces a lot of pain for when you're moving around because there's less things to be able to absorb that shock of like constantly jumping or running around. So yeah, that's basically every major structure in the synovial joint. So we're going to look at the types of synovial joints because they each allow for different types of movements, and there's 6 of them really. So the first one we're going to look at is the gliding joint, and these ones are kind of odd because they don't really seem like the shape of a synovial joint, but they are. And these are really only found in your hands, and they allow for certain types of gliding movements in your hands, which are not super exaggerated, but because there are so many smaller bones in your hands, they need these like finite movements to keep them highly mobile. And this means that the joints allow for side-to-side movement, and out of all of the synovial joints, they provide the least amount of movement. The next one is the hinge joint, and the hinge joint, a really good example of, is just your elbow, because your elbow can only move and extend one way, it can't go the other way. So really, the hinge joint is just one of your bones fitting into concave structure of your other bone. And this ensures that, like, because it's a reciprocally concave surface, it can really only bend and straighten in one direction, but it does allow full range of movement in that singular direction. The next type of joint we have is the pivot joint, and the pivot joint it allows for a bone to rotate around another bone. So the one example I have here is the radius rotating around the ulna at the radial ulnar joint, which is your joint below your hinge joint on your elbow. So if I hold my upper forearm like this and I rotate my forearm, this is able to rotate because there's another pivot joint inside here separate from the hinge joint from earlier. The next one is the condyloid joint, and it's kind of like it looks kind of like a ball and socket, but it's like an oval or egg-shaped surface fitting in a reciprocally shaped concave structure, and allows for movement in two directions. So one is like your fingers can rotate like that, but another one is just your wrist. Your wrist can rotate because your wrist fits into the rest of your arm in a condyloid joint. Then the last two I have is the saddle joint, which is found in your thumb right here, and it sits in a saddle shape. And then they really allow for kind of just rotation in two directions, which is side to side and also up and down, which is why you can sometimes move that way. And then the ball and socket joint, which is your hip joint and your shoulder joint, which allows for full rotation. And it's kind of similar to a condyloid joint, but it's more spherical and it allows for the greatest amount of movement. Yeah, so that is all of the types of joints. Yeah.